second day for this paper. So for summary, yeah, let's briefly read this abstract. So in breast cancer, radial alignment of collagen fibers at the tumor matrix interface facilitate collective invasion of cancer cell into the surrounding stromal matrix. Critical step toward metastasis. You know metastasis, right? When cancer cell want to go other side, which is called metastasis. Collagen remodeling is driven by proteins and cellular force, mediated by matrix mechanical plasticity or irreversible matrix deformation in response to force. However, the specific mechanism causing collagen radial alignment remain unclear. Here we study collective invasion of breast cancer tumor spheroids in collagen-rich matrices. Increasing plasticity to breast cancer relevant ranges facilitates invasion with increasing stiffness, potentiating from single cell to collective invasion. At enhanced plasticity, cells radially align collagen at the tumor matrix interface prior to invasion. Surprisingly, cells migrate tangentially to the tumor matrix interface. Tangentially means that when you imagine the spheroid, this side, right? Not the radial. Radial is central to outside. Tangentially means that perpendicularly to the tumor matrix interface in a swirling-like motion, perpendicular to the direction of alignment. Mechanistically, swelling generates local shear stress, leading to distally propagating contractile radial stresses due to the negative normal stress, an underappreciated property of collagen-rich matrices. These contractile stresses align collagen fiber radially, facilitating collective invasion. The basal membrane, which separates exterior from stroma enhanced tissue, acts as a mechanical insulator by preventing swelling cells from aligned collagen. Thus, after reaching the basal membrane, swelling of breast cancer cell at the tumor stroma interface gradually align collagen to the fascial invasion. So for your memory, yeah, let's briefly see our concept here. So this is like perfect cancer, in situ cancer, which didn't show metastasis. Oh, sorry. Oh, second. Hmm. Yeah, sorry. Yeah, so as you see, this upper one is aligned fiber, collagen fiber structure. Now how this alignment can help the metastasis of the cancer. They are clockwise moving. Some are moving like this, right? So when they compare this tangential means this moving. If we can see this. Oh, okay, sorry. They're moving like this. So tangentially, they're moving faster than the perpendicular moving from inside out. Make how they make the collagen one fiber alignment, right? We want to know. For answering that, circle. But as I showed you before, cell when some cell is going this way, collagen fiber, they can be stretched. You can easily imagine, right? But the thing is that this gray fiber, yeah, they're compressed force. Mm. Actually, it's not easy to imagine like this fiber, little like smaller fiber, smaller distance fibers. Hydrogel and IPC tissue covered by fiber network simulation. shear stress like this. Okay, they are moving like this. When they're making this stress, as a result of this shear stress, this normal stress we can observe. And then not only this hydrogel, but also this cancer cell tissue, they can observe in the same manner. So let's imagine. So in cancer cell tissue, again, this swirling cell motion. This way, this is kind of left and right shear stress. So while they're making shear stress, this can make some negative. Also, they are same direction, right? There's from this graph, for left one, minus shear. From this random fiber structure, they are making this kind of red one is stretched collagen. The blue one, somehow they are compressed. So, and fiber on the stretch, they are This is the same thing. Minus, minus, plus, minus. And then normalize manner. The tangential deformation and spherical interface and distance radial contribution force, they can make the collagen one alignment, right? Here, minus, plus, minus, minus, something like that, right? Here, radial probably around cell ischium interface. Definitely tangential that much, right? Here, blue is very dominant. So this is their meaning. That dipole, like dipole means two different like location. Dipole, monopole, dipole two. Dipole like shear force, align collagen motion inside, and automatically this kind of dipole like shear force happen. And then at the same time, radial directionally, this contributed force happen. How can I say it? Their theory, how this kind of thing happen theoretically, and then they try to observe the real phenomenon from the spheroid and cancer tissue, and then they build up their hypothesis. And then to support the hypothesis, mathematical. Next time. For example, when you culture the cell, your experiment, your hand, you can observe in the same manner. It is the beauty of the simulation. Ask, okay, you already collagen fiber and what happened? You are using. But here, when they use the fibrous collagen fiber, and then they can make this kind of speed. And then this dipole like moving. Maybe this, sorry, DF is coming from another one. Okay, this, okay, sorry. You can observe dipole like this. So right here, this is totally different from what we observed before, right? It's interface difference we can observe, but this exponent value, there's no direction. And then again, now we always also should be very important. And then section as well, because protein, another important protein for regulating sexual interaction, which formation dramatically is going down, and the deformation component also Silicium adhesion inhibitor, beta 1 integrin blocking, and the fat service. So all of them they're going down. Again, this and then this average deformation all go down, and then this is other way. They should but beta blocking integrin single one is not enough to govern this kind of phenomenon. Published a paper regarding this phenomenon before. This basal membrane, what's the meaning of this basal membrane? They can confine the so they culture the cancer cell and then they culture them like so this is their initial perfect basal membrane and then collagen fiber. Actually, what is the meaning of this? Third, it's basal membrane for themselves. And then So let's say the wonder cell, they're making perfect basal membrane here. Is gone, right? Wonder is gone. The basal membrane lies a width here. And then basal membrane acts as a physical barrier between perfect basal membrane, but over time, 5 days, basal membrane gone, while they're more here, right? Here, quite a lot. The radial is so dramatic, right? So this is the meaning. Laminin location. But the laminin is gone. Their swelling induce force that can transmit to the other side, ECM. And then this different deformation is initially tangential. Also similar tangential perpendicular difference velocity. You can see so with intact basal membrane, they track the cancer cell. Some cancer cells have an intact basal membrane. Right? So to confirm those kind of hypotheses, they track the collagen like elongated. You can see a lot of like radiative. Radial means the blue color is a lot. The collagen is somehow later shielding stronger collagen 1 from swelling epithelial cell. So from overall all the inside the membrane, these cells are swirling. They're moving inside of the membrane. Their stress is shielded by this basal membrane physically, right? So they cannot make very strong certain the difference between this tangential force here and then radial force here. Their own pathway, their own highway. This is their highway for the cancer. They want to go other side, so they are this cell motion is a major component for making this kind of this collagen fiber alignment. And then this cancer cell or cell interaction using certain inhibitor or certain chemical. Also, you can stop because yes, this simulation is we think about right. Well, first time you observe, okay, 4 hour, 12 hour, 24 hour. Hour, how they move, and then you can feel something. So, and then I of the phenomenon. But if you observe the real phenomenon, live images, like 12-hour overnight, definitely we can find any kind of expertise. Mm. And I want you to try to learn and know